Hello students. So this topic 2.3 notation for different numeral systems will not appear in your UT and exam in Form 3, but it will appear in your public exam. So I will simply do a dictation of my lesson using this Explain Everything app. And suppose we have a Denary number like this one, 3,824. And we all know that each digit has actually a different place value. So this will be 1,000, 千位, and this will be 100, 百位, and this will be tenth, and finally this will be in unit. And since we are doing with Denary numbers, Denary, we can realize that this is actually unit. 1 and 10 stand for 10, and 100 is 100, and 1,000 will be 1 followed by 3 0. And we can all see that these are all exponents of 10. And this one is 10 to the power 0, 10 to the power 1, 10 to the power 10 squared, and 10 to the power 3. So 3,824 in Denary actually means 3 times 10 to the power 3 plus 8 times 10 squared plus 2 times 10 to the power 1 plus 4 times 1. And so, what if we have binary numbers? 一正数. We have binary numbers. That means we don't have 2. We only have zeros and 1 in each digit. What does this number mean? 1101. This is not 1,101. We just call this 1101. And since we have a binary here, therefore we change the base from 10 to 2. So this number will be 2 to the power 0. This 0 will be 2 to the power 1. This will be the square of 2. And this will be the cube of 2. And therefore this will be 1, 2, 4, and 8. These represent the place value of each digit. And therefore 1101 actually means 1 times 2 to the power 3 plus 1 times the square of 2 plus 0 times 2 to the power 1 plus 1 times 1. And in fact, we can actually add up this number. This will be 8 plus 4 plus 1, which is 13. This will be 13 in base 10. This is base 10. This is base 2, binary number. So let's see another example. We have this binary number 100111. We have base 2. How can we convert this to a Denary number or decimal number? And this place value will be 1, and then 2, 4, 8, 16, and then 32. And now we can simply add up all those numbers. We have 32 plus, and since these are all zeros, we can simply just ignore them. And then 32 plus 4 plus 2 plus 1, and this will be 39, base 10. And now let's look at an example. Write the following binary number in the expanded form. We have in A, we have 11010 base 2. And since each digit has a different place value, so the first one will be 1, 2, square of 2, cube of 2, 2 to the power 4. And we write this 1 times 2 to the power 4 plus 1 times 2 cube plus 0 times the square of 2 plus 1 times 2 plus 0 times 1. And this is the expanded form. And in fact, we can find the actual Denary value from this expanded form. And this will be 16 plus 8 plus 2. and this is 26 base 10. And for part B, this will be 1101. Therefore, we have 1 times 2 to the power 3 plus 1 times the square of 2 plus 0 times 2 plus 1 times 1. This is the expanded form. And we can convert this to a Denary number. 8 plus 4 plus 1. We have 13. And for hexadecimal number, 16進數, it seems the problem will be a bit difficult, but actually the concept is still the same. But one thing will be quite different, since we have a hexadecimal 逢16進1. Therefore, we don't have 10, 11, 12, 13, 14, and 15 in hexadecimal. We use alphabets to represent the numbers from 10 to 15. For example, we use A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. And therefore, if we have the number F3C in hexadecimal, then this C will have the place value of 1, and this 3 will have the place value of 16, and this F will have a place value of the square of 16. And since C represents 12, therefore itself it will be 12, and F it will be 15. And therefore, if we write this in expanded form, this will be 15 times the square of 16 plus 3 times 16 plus 12 times 1. And if you check the value using a calculator, this will amount to 3,900 base 10. So let's look at another example on hexadecimal digit. Write this number in expanded form. So the place value will be 1, 16, square of 16, cube of 16. And F represents 15, remember. And therefore, the value of this number will be 15 times the cube of 16 plus 0 times 16 square plus 4 times 16 plus 6 times 1. So this is our expanded form. So if we find the value of this expression using a calculator, we have 61510 base 10. So that's all for today. Bye bye.